Okay, these are your notes for side and angle relationships of triangles. This is chapter 9, stop 2, pit stop B. So side and angle relationships of triangles. So basically this is how do the sides and the angles in a triangle, how are they connected? Okay, so sides and angles of polygons. Polygons are shapes. So sides and angles of shapes having the same measure are congruent. So congruent means same. Congruent means same or equal. Okay, congruent means same. But in geometry, you're going to hear the word congruent. So if we say that they're congruent, that means that they're the same or they equal each other. All right, so in an isosceles, triangle, remember isosceles triangles have 2 equal sides and 2 equal angles. Okay, maybe we can write that over here. 2 equal sides and 2 equal angles. So isosceles triangles have 2 equal sides and 2 equal angles. The angles that are equal, okay, are the ones that are opposite the 2 congruent sides. So in an isosceles triangle, the angles opposite the 2 congruent sides are congruent. So what I mean by that is if I drew an isosceles triangle up here, these 2 sides are congruent, all right? That means that the angles opposite those sides are also congruent. So this side, the angle opposite from it is this angle right here. This side, the angle opposite from it is this angle right here. So these 2 sides are equal, and that makes these 2 angles equal. All right? These 2 sides and these 2 angles will be equal. In an equilateral triangle, remember equilateral, all sides are equal and all angles are equal or congruent. So in an equilateral triangle, all 3 angles are equal and each measures 60 degrees. Well, you may say, why do they measure 60 degrees? Well, if you think about it, all the angles in a triangle have to add up to 180. So if I had a triangle and all 3 angles were the same and they had to add up to 180, well, 60 plus 60 plus 60 equals 180. So that's why in an equilateral triangle, every single angle equals 60 degrees. So this is kind of stuff that we needed to go over before we can go and determine values of x's and y's. Okay, so for our example, it says write and solve equations to determine the values of x and y in the figure. So on number 1, they want us to determine the value of x. All right, and if you look here, I just want to bring this to your attention. I'm not going to really look at this so much because it gets kind of confusing and wordy. But if you look over here, it says M angle A. Well, M angle, this stands for the measure of angle, and then blank, you fill in the blank. So this says the measure of angle A. This one says the measure of angle C. So when you see M angle, that means the measure of angle and then whatever angle they tell you. Okay, so they want us to solve for x. So here's x. This is an isosceles triangle because these 2 sides are equal. That makes these 2 angles equal. So since this angle equals this angle, they're congruent, that means I can say 6x equals 48. Now all I have to do is solve for x. So cut it in half, isolate your variable, divide both sides by 6, because dividing by 6 is the opposite of multiplying by 6. 6's cancel. 48 divided by 6 is 8. So that means that x equals 8. And if I plug that back in, 6 times 8 is 48. And 48 are the same angle. So I did this correctly. Okay, so maybe let's try that now. They want us to solve for y. So because this side has one tick mark and this side has one tick mark, that means they're the same. So these side lengths are equal. So that means that 7.8 equals y plus 1.4. Well, one-step equation. Cut it in half. Isolate your variable. The opposite of adding 1.4 is subtracting 1.4. Do that to both sides. My 1.4's cancel. 8 minus 4 is 4. 7 minus 1 is 6. So y equals 6.4. If I plug that back in, 6.4 plus 1.4 is 7.8, and 7.8 equals 7.8. So yes, I did that right. So basically what they're getting at here is in an isosceles triangle, 2 equal sides, 2 equal angles, these sides equal each other. Okay, so I can set this side equal to this side and solve for the variable. And these angles equal each other. So this angle equals this angle. Set them equal to each other and solve. All right. So if I wanted to fill this in, the values of x and y in the figure. Well, x we said was 8 and y we said was 6.4. Okay, so let's go down here and let's do 2 examples. Okay, so they want us to solve for x and y in each figure. So let's start with x. Notice 1/2 times x is a degree, and this is 52 degrees. So a degree has to equal a degree. Degrees go together, side lengths, feet and feet go together. All right, so that means that these 2 angles equal each other. So 1/2 times x equals 52. Now let's solve. Cut it in half. Opposite of multiplying by 1/2 is dividing by 1/2. Okay, so I'm going to divide by 1/2. My 1/2s cancel. Well, I'm dividing fractions, so let's put a 1 under the 52, and I'm going to keep, change, flip. So 52 over 1, keep, change, flip, 1/2 becomes 2 over 1, top times top, bottom times bottom. 52 times 2 is 104 over 1, which is the same as 104. So x is 104. Okay, now let's do solve for y. So this side of 3.2 feet equals this side of 4y feet. Okay, feet go together. They equal each other. So 3.2 equals 4y. This equals this. 3.2 equals 4y. Cut it in half. Isolate your variable. Opposite of multiplying by 4 is dividing. Do that to both sides. My 4's cancel. Tie bow, top in, bottom out. 3.2 divided by 4. Take your decimal up. 4 won't go into 3, but it will go into 32 8 times. So y equals 0.8. Y equals 0.8. All right. Number 2. Let's solve for x, our degrees. So, what kind of triangle is this? Well, 1, 2, 3. It has 3 equal sides. All the sides are equal, so that makes this an equilateral triangle. And an equilateral triangle, we learned that every single angle measures 80 degrees. So every angle is 60 degrees. So that means this angle 60, this angle 60, and this angle is 60. So 3x has to equal 60. So I'm going to cut it in half, isolate the variable. The opposite of multiplying by 3 is dividing. Do that to both sides. My 3's cancel. X equals 20. 60 divided by 3 is 20. Okay, now let's say y. So remember, in an equilateral triangle, every angle is 60 and every side is the exact same. So that means this side of 16.9 inches equals this side of y minus 3 inches. Inches go together. So 16.9 equals y minus 3. 16.9 and y minus 3. Cut it in half, isolate the variable. Opposite of subtracting 3 is adding 3. I'm going to add 3 to both sides. Now be careful where you put your 3. 3 is a whole number. It's in the ones place, so that goes under the 6. It's like saying 3.0. 9. 6 plus 3 is 9, and 1. So y equals 19.9. Guys, remember, if you're going to add a decimal to a whole number, it always goes at the end. So that's like saying 3.0, which is what I got here. That's how I know to line them up. All right, so this is how you determine x and y in triangles like this. You got to figure out, is it isosceles or equilateral? If it's equilateral, you have to remember that every angle is 60 degrees. Okay, 60, 60, 60. All right, so these are your notes for side and angle relationships of triangles.